There are also handy commands for extracting rows and vectors from matrices in MATLAB. We'll create a matrix A containing 3 rows. To extract the second row from this matrix, we can also use the colon to indicate that we want all of the columns in the second row. This gives us all of the columns in the second row as a row vector. Or we could extract all of the rows using the colon in the row index from, say, the third column. So this gives us a column vector containing the elements of each row, the colon, in the third column, the 3. Sometimes it's useful for us to extract the elements along a diagonal as well. That can be done using the diag command. The diag command with the argument a will extract the elements of the diagonal and put them into a column vector. The diag command can also be used to extract elements off the diagonal. For example, if we want to take the elements above the diagonal, or what's called the super diagonal, we can enter a second argument, 1, indicating that we want everything one row above the diagonal. That's the elements 2 and 6. Or alternatively, if we want the subdiagonal, we put -1 in for the second argument, and that gives us the elements 4 and 8. Nesting the diagonal command does something perhaps you wouldn't expect. The inner diag command extracts the diagonal elements from A, and the outer diag command creates a new matrix that has zeros on all the off-diagonal elements and the diagonal elements of A along the diagonal of the new matrix. This can be used to effectively set all of the off-diagonal elements of a matrix to 0. We may not want to set all of the off-diagonal elements to 0. If we want to retain the upper diagonal elements and only set the lower diagonal elements to 0, we can use the trie_u command to extract the upper triangular matrix from A. And similarly, we can use the trie_l command to extract the lower triangular elements from A. Now that you know how to assign and extract elements from matrices, you can use these simple commands to perform a lot of important linear algebra functions. In the next couple of videos, I'll show you some of the symbolic math tools that are available to you in MATLAB.